So friends, in this video I'm going to show you how we are gonna train our logistic regression model using our final data which I have mentioned in the above video, that is better width and sepal length, which I have considered as the features which are going to affect my target data. And so my target data is I have also stored that in separate data frame. I'm going to say how why did I do that. So let's get started. So from right at the beginning, I'm going to use sklearn.linear model, which is actually sklearn consists all the machine learning models in it, and so basically I'm importing the basic linear model, which is the logistic regression. And I have also made a video on logistic regression. You can go check it out. What is the math behind the logistic regression. So I have imported my logistic regression from sklearn and now have made the instance from a logistic regression model, which is nothing but logic reference. And now again, in the before video, if you observe, I have made two data frames, which is my final data frame and target data frame. I have made that because I need to split them in my train data set and test data set. Now this is the biggest part which you need to understand, friends, because I need to use this train test split method, because suppose in my given data set I have, if you can see, where's my data set, if you can see, I have 150 rows and 5 columns, isn't it? So in this 150 columns, in this 150 rows, I'm going to select few instances for training my data, for training my logistic data. And as I train it on my training data, if I train my logistic regression on my training data, and I'm going to predict how well my model is going to perform with the help of another data, which is nothing but my test data. So I'm using this train test split in order to split my final data and my target data into two sets, which are basically my X train and X test. If you can, this X train is basically used to train my logistic regression model, and this X test is basically used to observe or make a note how my logistic regression model is functioning, how well it has learned my training data. So this X test is basically used to know our model prediction, isn't it? So this is why I have made my final data and target data in order to send it into my train test split. And if you can observe here, I have a variable test size equals to 0.3. 0.3 in the sense, in my entire final data, which has 150 rows, this 0.3 in the sense 30% of my entire data, I'm going to make it as test size. That means 30% of my entire data is going to be split into X test, which I will be further using it to predict my check whether how my logistic regression model is performing. So if you can observe here, this is my X train dot shape and Y train dot shape. This is my these are my data frames which I'm going to train my model. So let us see their shape. So if you observe training set, I have 105 rows in my X train and 105 rows in my Y train. Y train is basically my target variable. So these are the shapes, and if you observe them, I have 105 rows in my X train and 105 rows in my target variable. It should be same because the instances are actually interrelated, isn't it? So I have 105 rows. In the sense, I have 105 rows, and with respect to that, I have 105 target variables. So that my model will get trained on all the 105 instances. Is 105 training instances must and should have 105 targets, isn't it? So we need to observe this thing that both the training sets must have equal number of instances. Same with my test test set. You can observe I have 45 and 45 instances, which this 45 number basically comes from my the test size. If I change my test size, my the number of instances splitted into my test x test also differs. And now if I'm using fit function to train my logistic model with the help of logistic regression instance. So I'm passing xtrain and ytrain as my training data sets. So when I execute this, my logistic regression has trained based on my given data set. Now basically I'm going to predict my xtrain values. I have splitted xtrain. So I'm going to predict the target variables for my entire xtrain. So let me see what all instances I have in xtrain. So if you see, I have instances like 0.2 and sepal length 5.0, 1.4, 5.2. These are my instances I'm going to pass into my logistic regression.predict. So what my logistic regression does is it gonna return an array which I'm going to store it in ypredict, and this ypredict is basically the predicted target variables for my given test data set, isn't it? So let me print that ypredict. So if you see, I have printed the predictions made for my logistic regression model. If you see here, ypredict is 0, 1, 2, 3. So what I have done is I have chosen my xtrain, which is nothing but xtest, which is nothing but this data set, and I'm going to predict the corresponding target variables for each of the instance, and I'm storing it in ypredict. And if you can observe, when I printed my ypredict, these are all my predicted values. Now what I'm going to do is I'm going to compare these predicted values with my original y-test. This is the y-test which corresponds to my x-test values. Okay, let me show you. So x-test. This is my we print here y-test. So for my 35th instance with petal width 0.2 and 5.0, my original flower is of kind 0, isn't it? And for my 59th instance, my original flower is 1, which corresponds to versicolor. If you observe my ypredict, and these are my values corresponds to the predicted values which my logistic regression model has predicted. So now I'm going to compare them both. So I'm comparing them both, the original prediction and the original values and the predicted values from my logistic regression. So here I'm basically constructing a data frame, and if I print the data frame, I haven't sent anything like data or columns from my data frame. So it is basically having nothing, neither a column nor a row. So I am creating my data a column naming original values, which is nothing but xtest dot values. So if I print data, so if I execute this, if you can see that my original values, I have made a data frame, and again I'm going to include another column named predicted values to my data frame. I have executed, and I'm going to print it. So now if you can observe here, I have included both original values and my predicted values for my X test data set. So if you can observe, for my original value, my model has predicted 0, which is same. For my original value 1, it has predicted 1. And if you can observe the 28th row, what happened is, for my versicolor flower, my model has predicted 1, which is the first kind. Let me say what. So here for my actual 2 value, my model has predicted 1. This has predicted wrong. So let me see up to which extent my model has predicted. So I need the accuracy actually. I'm saying about the accuracy. So I have the metrics. I'm going to explain it about it further in my videos. But for now, I'm going to import it from sklearn, which is from that I'm going to import accuracy score, which gives how accuracy score basically examines how the original value and predicted value are differing, and based on that it gives the accuracy. So I have used accuracy score on my predicted values from the logistic regression model, and y-test, which are the original values for my x-test dataset. So when I execute this, you can observe that my accuracy score was 0.55%. That means my logistic regression model was able to predict 95% accurately. This is how my logistic regression model is being trained from a given dataset. So thank you for watching this. So I'm going to make a huge amount of videos on my new channel. So please consider subscribing for more videos. Thank you.